Okay, so now we're recording. Again, this topic is, well, I'll just write it down so you guys have it. It's writing a mixed number and an improper fraction for a shaded region. Okay, so that's the topic. So this isn't bad, right? So we have 3 circles here. How many of them are completely filled? We have 2 of those, correct? And then we have one that's only half filled. And so one of the things that you'll notice, though, is they've broken it up so that it's already set up in the right fractions. Yeah, and you shared the answer. They're set up in halves, right? So how many total halves do we have? We have 1, 2, 3, 4, 5, 6. So we know that in this problem we have 6 halves. How many of those 6 halves are shaded? We know 5 of the 6 halves are shaded. So that's how we write it. So we write it as 5 over 2, and then that becomes 2 1/2. For those of you who, well, we could see it here, right? So we have how many halves? We have 1, 2, 3, 4, 5 halves, or we could think of it as 2 solid circles and a half. Another way to be able to turn it into the 2 1/2 would have been to go like this. How many 2's go into 5? 2 go into it. What's our remainder? The remainder is the numerator of the fraction. So this is the whole number. This, oh, oops, sorry. This remainder is the numerator, and then what do we divide by? Maybe I'll do that in color. So this is the whole number. This is the remainder. And this is what we divide it by. Just so you guys have it in color sequence so you can see it. Okay?
Professor, we can't see anything you're writing.
Oh, really?
Yes.
Oh, bizarre. Okay, let me see.
There you go. It's right there.
Oh, strange. It went. That must be a Zoom thing because I was sharing my screen the whole time. You can now see it?
Yes.
Yes.
Oh, strange. Yeah, Zoom's had some problems, unfortunately. But I'm glad you can see it now. Does that make sense how I wrote that? Do you want me to re-explain that so you guys can see it? Or are you okay?
No, it's quite fine.
Okay. All right. So let me do another one for you, and we'll see how you guys do. Okay. Oh, okay. Yeah, I'm gonna do another one, and then we'll go from there. Okay. So we have, let's say we have a circle, and I divide it into fourths. And I'll just do 3 for fun. I usually think it's easier to do the mixed number, or I'm sorry, the improper fraction, and then do the mixed number. That's just me. You may be different, but it's just the way I think of this thing. So the first thing that we want to look at is how are these circles divided? They're divided into groups of 4, right? So that tells us that the denominator of this thing should be a 4. Okay, it's like quarters. How many of the quarters are shaded? That's right. So we have 11 of them shaded. So this is what we would say the improper fraction. Now, if we want to look at it in terms of whole numbers, how many complete circles are shaded? We have 2 complete circles. And then of the partial circle, how much of that is shaded? And we can see in the partial circle we have 1, 2, 3 that are shaded. So that's going to be our numerator. And then the 4, because it's divided into 4 pieces. Does that make sense? Okay. Itzel, does that make sense to you? Okay, cool. Do you want me to show you how to do it so you guys can see how to do it this way also? Okay, no problem. So to do that, what I'm going to do is I'm going to take the numerator of this thing, so that's the 11, and then I'll use a different number for my divisor. What did I use? I used blue. So this is the blue number. Now, how many times does 2 go into 11? We should see that to be 5, right? So then 5 times 2 is 10. We're going to subtract that. And then what we're going to end up with is a remainder. And the remainder here is, oh, what did I do? 11. Oh, I divided by the wrong silly number. My bad. This should be a, I was looking at the other number instead of doing it this way. Oh, my apologies. You guys are all probably like, what is he doing? Okay. Sorry, you should be dividing by 4s. So it shouldn't be a 5 here. This should actually be a 2. And then 2 times 4 gives me my 8. And then my remainder that's here is going to be 3. So when I go to write this thing, we can see it's going to be 2 is my whole number. 3 is my remainder. And I divide it by 4. And that's how I can write it that way. Does that help? All right, cool. Now, one thing I do want to stress for all of you is how important it is for you to be doing your work on Alex. That's where your tests are. That's where your homework is. So if you're not getting on there, you're going to be pretty far behind, and unfortunately, that's going to really hurt your grades. So please make sure to get in the habit of getting on Alex daily. It's important. Okay. So this next problem, let me see if I can get to the point where I can show you. That topic is simplifying a ratio of multivariate monomials. So here I'll write it down too. So this one's topic is simplifying. Oops. And we all know that a ratio is just simply a fraction, correct? On the trying to break it down as basically as possible is just a fraction. So that's the topic. So in this example that we're going to do here, I'm going to try to simplify this thing by reducing as much as possible. So I want to break these numbers up that we have, the 35 and the 42, in such a way that I can cancel something. So the way I see it is I see 35 as 5 times 7 times A times B, right? Because 5 times 7 is 35. And then 42 I know to be 6 times 7 times A times B. And now this shows me all of the numbers that they have in common, right? So the 7 is on top and bottom, the A is on top and bottom, and the B is on top and bottom. And so this thing cleans up to be 5/6. Okay? This is like the simplest type of problem that you're going to see. There will be more complicated ones, and I'll do one of those for you so you guys can see, but basically these problems, things should cancel out quite easily. So let's say that I gave you something like, I don't know, how about 12A B C over 18 BC. What would that be? Do you guys want to try that? Okay. Well, we got a couple people. To break this thing down, I know the numbers that work, so I'm going to go 2 times 6 times A times B times C. And the bottom is going to be 3 times 6 times B times C. And then we see the C's will cancel, the B's will cancel, the 6's will cancel. And my answer here is going to be 2A over 3. Are we okay with that?
Yeah, I'm okay with that.
That seems pretty reasonable for you guys. All right, you want me to make it a little bit more complicated so you can do topics that are a little bit more advanced in this same area?
Yeah.
All right, I'm going to do one just so you guys can kind of look at it. I think it's valuable. So if I gave you something like 15A squared times B to the third over 18A times B to the fourth, this is more complicated, much more complicated, right? But we want to break this down in such a way that we can see it. So I know I'm going to go 3 times 5, and then it's going to be A times A, right? Because A squared just means A times A, times B times B times B. And then in the denominator, I'm going to go 3 times 6 times A times B times B times B times B. Does that make sense to everyone?
Yeah. So you're basically like simplifying it.
Yeah.
By down to its very core.
Yeah. So instead of using power rules, it is stuff that we use more in like intermediate algebra or in Math33. Let's just break it down so we can be successful, and then we can apply the rules later. So then this will cancel this one, this will cancel this one, this will cancel this one. This cancels the A's, this takes the 3's, and we can see, we're going to end up with 5A over 6B, and that would be the answer for this one. A little more complicated, but very doable, right?
Yeah.
Are there any questions on this one at all?
I can think of.
No? Okay.
I'm not sure if anyone else needs it.
All right, let me go to the next. And let's see if I can find the name of this one. So this topic's called Fractional position on a number line. All right, so with this problem here, one of the things that we can see is right here, this is 1, here is 2, here is 3, right? I mean, we can see the little numbers there, but I just wanted to write it so you can clearly see it. In between each number, how many little dashes are there?
I'd have to say maybe 5.
So there's 4 in between, right? You see how there's 1, 2, 3, 4. But to get to the next one, there is 5. So we're always, for our fraction here, the denominator is always going to be 1 more than the number of dashes between the numbers.
Okay.
Okay, so how many dashes do we have? We have 4 dashes, but the denominator is always 1 more. So I know that my denominator is going to be a 5, and then we got to start with our position. So we're starting at 0. So how many dashes do we go over to get to A? 1, 2, 3, 4. And so this answer for A is 4/5. Does that make sense to everyone?
Yes.
Okay, let me create another one. So let's say I gave you a dot right here, and I'll call it B. So now what we want to do for B is we're going to go whole numbers, so we want to write it as a mixed number. So what numbers are we between? What whole numbers are we between?
At least 2 or so.
Yeah, we're between the number 2 and we're between the number 3. So we know, since it's between there, the whole number is going to be 2. We already know how many dashes there are, so that the denominator should be a 5, right, in doing the mixed number. How far are we away from the 2?
Like 2 spaces.
1, 2. And so this is 2 and 2/5. Does that make sense?
Yeah.
All right.
I struggled a bit on this, to be honest.
No, a lot of people trip out because they forget to add 1 more to the number of dashes, right? So let me do another one for you. Let's say this is 0. Here's 1. Here's 2. I'll just stop right there and I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if I did that and I said, all right, let's call this A, what would A be equal to?
About 1, 3 over 5/5.
So it's 1. You see it is 3, but now to decide the denominator.
I'm still used to the last one, yeah.
Yeah, when you look at the denominator, how many dashes are in between? There's 1, 2, 3, 4, 5, 6. But remember I said you needed to add 1, so it should be a 7.
Yes.
Very nice, Catalina. Does that make sense?
Yes.
It's pretty straightforward if you can remember the add 1 to the number of dashes. It should be very straightforward. So right now I think about 1/3 of the class is ready to do this for all of these topics that I'm talking about. So after me explaining it, it should make it so it's much more manageable for you guys, I hope. Does it seem clear?
Mm-hmm.
All right. Okay, let me go on to the next one. And this, I believe, is just called reciprocals, right? Finding the reciprocal. Yeah. So this is the reciprocal of a number. And what does reciprocal mean in mathematics?
Flip?
Yeah, pretty much just a flip. So we need to understand how all these numbers are written as a fraction. So that number 10 that we have there really is 10 over 1, correct? So if we have 10 over 1, when we go to flip that, it is 1/10. And so this answer is 1/10. Okay? The 8/9, we need to flip that. So that becomes 9 over 8. So this is 9 over 8. And that is the reciprocal. Now, I do want to make it a little bit more complicated because they're not always just going to give you a fraction or a whole number. Sometimes they're going to give you a mixed number. So if I gave you something like 3 and, 4/5, do you know how to make 3 and 4/5 into a improper fraction? Because that's what we need to be able to do. Is there anyone that doesn't? Be honest, I'll explain it. Or if you're unsure, speak up.
19 over 4.
Yeah, so very close. It's 19 over 5.
5, sorry.
Yeah, 19 over 5. Does anyone need me to explain how we got that? I can do a big old diagram. Okay, so look at this. So I'm going to write it so it's a big old diagram. Actually, I want to get even bigger. 3, 4, 5. So the way this direction goes is we're going to go in colors. So first you're going to go this way. And what we do here is we multiply. Okay? Then, so this is step 1. Then, in fact, it's Christmas time. We're going to go this way. And here now we add. So the way that this works is I'm going to get 5 times 3 is 5 times 3 is 15, right? Well, here, actually, let me write it down so you guys can see. And I'll do it in color so you can see. So I'm going to go 5 times 3 and then plus the 4. That's going to be my numerator. So this is going to give me 15 plus 4, which is my 19. And then the denominator always stays the same. Does that help?
Yes.
Okay.
Much actually.
Yeah. It's a cool little diagram. And, you know, on the next exam, if you want, you can write that example for your for the exam. I know I said no examples, but this is one that I think it's a process. So that's the process. I can even go generic if you want and use it letters, but that might confuse you. So now that we have that, to find the reciprocal, right? To find the reciprocal of this, the reciprocal of 19 over 5 is 5 over 19. We okay?
Okay. Very good.
Yeah. So there are 4 topics for you guys that you can use to get your homework done between now and our next class meeting. Are you finding that the homework's getting easier and easier to do now that you're getting some practice?
Yeah.
That's good.
It is.
That's good. Okay, so that's all I've got. Do you have any questions for me before I let you guys go work on Alex?
Particular.
Okay. I want to make sure that you guys are feeling comfortable and feeling like you're making some progress and feeling successful. If anyone wants to talk to me, by all means, you're welcome to stay on. I'll stay on for another like 5 or 10 minutes, just to see if anyone needs any help or anything. Maybe they didn't want to speak up in front of everybody, that's fine. But those of you who are feeling comfortable if you want to hop on to Alex, please do so, and email me if you have any questions. Okay, I'll stop the recording now.